Hello and welcome to Excel Mathematics TV. In this presentation, we will be learning how to solve products of powers. In order to solve product of powers, we should first know its definition. Product of powers can be represented as the product of a raised to m, and a raised to n equals a raised to m plus n, where a can be any number and m and n are integers. Putting it to words, it means that when we are multiplying powers with the same base, we just need to add their exponents. Sounds easy, right? To make it even easier for you when solving, let's practice by solving an example. Let's solve the product of the square of 3 and the cube of 3. As you can see, our example has the same base, which is 3. The exponents are 2 and 3. Just like what the definition said, add the exponents. 2 and 3. The base, 3, will stay the same. 2 plus 3 is 5. Therefore, the product of the square of 3 and the cube of 3 is equal to 3 raised to the 5th power. To understand the concept even more, let's have some more examples. Just like what we did previously, we will simplify the following powers using the product of powers. Before we proceed with the examples, keep in mind that the product of powers can only be used if the bases are the same. So if the bases are not the same, we cannot use the product of powers. First, we have b times b raised to the 4th power. You see, they have the same base. When a number or variable doesn't have an exponent written, its exponent is 1. So b is the same as b raised to the 1. Having said that, we can rewrite the expression as the product of b raised to 1 and b raised to 4. Now what we will do is just add the exponents. Then our solution will become b raised to the sum of 1 and 4. Everybody knows that 1 plus 4 is 5. So, b is raised to the 5th power. We can say raised to the 5th power or simply say raised to 5. Thus, the product of b and b raised to the 4 is b raised to 5. As simple as that. Let's have some more examples. Solve negative 5x cubed times 2x raised to the 7. What do you notice? In this example, we have constants and variables together. To solve, the first thing we need to do is to simplify the expression by means of multiplying the coefficients of the variable. The coefficients are the constants, negative 5 and 2. We will isolate them from the variable x, and we have the expression, the product of negative 5 times 2 and x cubed times x raised to the 7. Negative 5 times 2 is negative 10. Then the expression will become the product of negative 10 and x cubed times x to the 7. The expression is now simplified. But look at the powers. They have the same bases. Both have a base of x. So what's next? Just add the exponents and the expression will be simplified to negative 10x to the 3 plus 7. Simplifying it even more gives us negative 10x to the 10. That's it. We got our answer. Thus, negative 5x cubed times 2x to the 7 is equal to negative 10x to the 10. Next, we have the product of 6c4 and negative 3c4. Again, the variables in the expression have coefficients. So we need to simplify that first. To do that, just multiply the coefficients 6 and negative 3. Then isolate them from the variables. 6 times negative 3 is negative 18. So the expression will become the product of negative 18 and c to the 4 times c to the 4. The common base is c. So just add the exponents and put c as the base. The exponents are also the same, 4 and 4. 4 plus 4 is 8, so the answer is negative 18c to the 8. Thus, the product of 6c to the 4 and negative 3c to the 4 is negative 18c to the 8. We will solve two more examples in simplifying product of powers. Let's have negative 7w cubed times negative 6w squared. Multiply the coefficients, negative 7 and negative 6, and the expression will become the product of negative 7 times negative 6 and w cubed times w squared. Remember, negative times negative is positive. So the product of negative 7 and negative 6 is 42. The bases of the powers are both w. So we just add their exponents. Their exponents are 3 and 2. Adding them gives us 5. And then putting our answers all together, we finally get the final answer, 42w to the 5. Thus, negative 7w cubed times negative 6w squared is 42w to the 5. This will be our last example for simplifying product of powers. We have negative x squared y cubed z times 4x squared y to the 4 z to the 5. When a variable doesn't have a coefficient, its coefficient is understood to be 1. So the first factor there has a coefficient of negative 1, even if the 1 is not actually written. The other coefficient is 4. Before anything else, let's simplify by multiplying the coefficients, negative 1 and 4. That is negative 1 times 4, and we will just put them separated from the variables. Negative 1 times 4 is negative 4. So we have negative 4 times x squared y cubed times z times a quantity of x squared y to the 4 z to the 5. As you can see, we have 3 different variables this time, and we also have 3 different bases. Even if the bases are different, there are pairs of bases which are the same, so we can still apply the concept of product of powers. All we need to do is group the common bases, like this. Now that the bases are grouped, we have 3 sets of powers with the same bases, and we will still follow the same procedure. Add the exponents, and the expression will become negative 4 times the quantity of 4x to the 2 plus 2, y to the 3 plus 4, and z to the 1 plus 5. After adding the exponents of the powers with the same bases, we get the final answer, which is negative 4 x to the 4, y to the 7, z to the 6. Thus, negative x squared y cubed z times 4x squared y to the 4 z to the 5 is equal to negative 4 x to the 4 y to the 7 z to the 6. We're done practicing and simplifying product of powers. This time, let's try some examples where we find the missing exponent. Let's have the first one. If we will multiply it by 2 raised to 5, what exponent should 2 have in order to be equal to 2 raised to 8? Let's go back to the definition of product of powers. Based on what we have said in the first part of this presentation, we can express the product of powers as the product of a raised to m and a raised to n equals a raised to m plus n. So this is the given. Let m be the missing exponent. In getting the product of powers, we need to add their exponents. I'm sure you already know that by now. So if m is the exponent of the first factor, we can say that m plus 5 is equal to 8. Do you know how to solve the equations? In the equation m plus 5 equals 8, we will just transpose 5 to the right side of the equation and change its sign. That is m equals 8 minus 5. We all know that 8 minus 5 is 3. So the missing exponent is 3. It's almost easy as subtraction. Let's solve the last example for today's lesson. This example is still about finding the missing exponent. If we will multiply p raised to a number by 4p to the 5 and p to the 4, and the product is 4p to the 10, what is the exponent of p? Once again, we will represent the missing exponent by a variable. The variable this time is x. To solve easily, we will write down all the exponents. Like what we said, the product of powers means that adding all the exponents for powers with the same bases. In this case, our bases are the same. So we have the sum of 5, x, and 4, and their sum is 10. Now let's work on the left side of the equation. We simply combine 4 and 5. Combining means adding, so 5 plus 4 is 9. So the equation will become x plus 9 equals 10. Next, we should isolate the variable x on one side of the equation to get its value. We will simply transpose 9 on the right side of the equation and change its sign. Doing that, our equation will then become x is equal to 10 minus 9. And obviously, 10 minus 9 is 1. And there you have it. The final answer is 1. Thus, the missing exponent is 1. That concludes the presentation for today. Now that you know how to solve product of powers, I hope you make great use of it. Always remember, practice makes perfect, so keep solving to master it. Thank you.